Hey guys! In the last video, I had mentioned that we're going to start doing some project competitions over on the forums. That's what this video is all about, but I'm also going to be giving kind of a crash course in getting started with Arduino, because that's what this one is going to be based around. So even if you're not interested in competing, there might be something in here for you. And I've been really excited to get the ball rolling on this, so let's get started. So the goal with these competitions is pretty simple. Encourage people to be creative, dive a little bit deeper into electronics, and maybe learn and try some new things that they haven't before, and just make cool stuff. And the way that these are going to work is each one's going to have a set of one or more required parts that you're going to have to find some way to use in your project. So kind of like those cooking shows where they have some crazy ingredient that they require that the contestants find some way to work into their recipe. Kind of like that, but there's not really going to be anything crazy. There'll also be a total budget that you have to stay under for all of your parts, minus shipping costs, because that can kind of fluctuate depending on where you live. But other than that, you can make whatever you want. So I'm hoping that this structure will kind of give people an equal footing and make everybody work within the same constraints, and avoid having some people that are able to just throw a ton of money at buying some awesome parts and building something crazy and just trying to win that way. At the end of the competition, probably in a couple months or so, people will go onto the forums, submit their project, show people what they made and how they made it, and then everyone can go and vote for which ones they like best. And there'll also be some prizes for the top projects as well. So that's the idea. We'll see how this goes, and if it goes well, this might be something that we do every few months. And we can adjust things each time that we do it, based on feedback from you guys. And check out the description for a link to a forum thread that'll have the most up-to-date rules and information, just in case anything changes, and links to parts that you need and things like that. So for this first project, you're gonna need 2 parts with a budget of $50. The first part is an ESP32, which is an Arduino compatible board that has Wi-Fi and Bluetooth. And even though we're talking about an Arduino board, it's actually pretty capable. In fact, if you happen to see the Pocket Sprite, which popped up on Kickstarter recently, it's a tiny emulation handheld that's actually powered by the ESP32. And it's able to emulate Game Boy, Game Boy Color, NES, Sega Master System, and Game Gear games. Pretty impressive for such a tiny low-power chip. So if you're just dead set on doing something gaming related for your project, you could actually do it with this if you wanted to. The second part that you're going to need is some kind of sensor. What kind of sensor is up to you. You can just go to Amazon and type in Arduino sensor, and you get back hundreds of results. Pretty much anything that you can think of. I mean, really, you name it. Color sensors, temperature sensors, barometric pressure, altitude, orientation, motion, proximity, light sensors, smoke sensors. I mean, the list goes on. And the best part is most of them are pretty cheap, like $5 or $6. So those 2 parts will probably take up about $15 or so of your budget, which should give you plenty of room to get everything else that you need for your project. For example, take a look at this that I was working on a couple of weeks ago. This is a smoke detector, and I never finished it, but the idea was I was going to add a relay and have it connected to my 3D printer, and if it detected smoke, it would send me a text message and cut power to the printer. And all the parts combined for this were under $20 or so. So you can probably get more than you think with that budget, and you don't have to use the whole thing if you don't want to. And a word of advice, if you're new to Arduino, then I would definitely recommend getting the ESP32 as soon as possible so that you can start messing with it and learning how to use it, even if you haven't figured out what you want to make for your project yet. And before I forget, I'm going to be giving away 2 ESP32 boards, along with a few things to help a couple of people get started with Arduino. So check out my Instagram account, there should be a post on there about it. And I'm not going to run it for very long, because if they go to somebody who wants to participate in the competition, then I want to make sure that they get it pretty soon. So when you go to get an ESP32 board, you'll probably notice that there are several manufacturers that make them. I actually went through a few of them before settling on the one that I was going to recommend for using in this competition. For example, this one doesn't have an onboard LED that you control, which I thought was pretty annoying. This one does, but it wasn't very well documented, and the board was actually too wide to fit in a standard breadboard. You can get cheaper ones like this one, which I got on AliExpress for I think like $7, and it will definitely work, and it's a little bit cheaper, but you'll have to wait probably a few weeks to be able to get it from China. So just know that they're not all one and the same. The pinouts are going to be different, some of the features are going to be slightly different. Just make sure that you're buying one from a reputable company and that it's well documented for things like the pinout and any drivers that you'll need. The one that I wound up settling on is this one from a company called HiLetGo, which in hindsight I should have bought to begin with, because I've used other stuff from them before and it's all been pretty good. But this one fits in a breadboard nicely, it's well documented, it was easy to get up and running with it. I think my only complaint with it is that the labels for the pins are on the underside of the board so that they could make it more narrow and fit in a standard breadboard. But like I say, their pinout diagram was pretty easy to find, and they actually even included one with the board. So this is definitely the one that I would recommend using after all the ones that I've tried. And also be aware that the pinouts will vary depending on which board that you're using. So if you're trying to follow along with the examples that I show or the source code that I post, just be aware that your pins might be a little bit different if you're not using this exact board. For the rest of this video, I'm going to assume that you don't know anything about Arduino and that you know at least a little bit about programming. I want to give everybody a good starting point, but if I started with the absolute basics of programming, this would be a very long video. So if you've never seen a line of code in your entire life, or if you're having a hard time following along, then check out the description and I'll link to a couple of resources that should at least help you get going. But if you're technically savvy, then I bet you can at least follow along. So Arduino is an open source platform of both hardware and software, and it's also the name of the company that owns and created it. They have a series of microcontroller boards that you can program to do stuff using input and output pins on the boards. They have several different kinds of boards with different input and output options and other capabilities. They're different from a Raspberry Pi in that they're not running like a full-fledged operating system like you might be used to. The way they work is you write small programs for them called sketches, and then you send those sketches to the boards using the Arduino development environment. Then when they turn on, they'll immediately start executing that program that you put on there. And a nice side effect of it being open source is that in addition to the official boards from Arduino, there are tons of boards that you can get from other manufacturers that are also compatible with the Arduino platform. This gives you even more options to find one that's just the right size and has just the right specifications for any given project. Everything from this big Bluetooth enabled one with a built-in battery and charger called the Beam Plus to this tiny little thing that you can fit into just about any project called the Arduino. And you can program them to do everything from control some LEDs to build a robot based around it, make a weather station that monitors weather conditions. I've even seen someone make an Arduino based pinball machine. And if you're familiar with my channel, you might have seen some of my earlier projects that used Arduino, like the lamp zapper. This uses two Arduino boards that talk to each other using infrared LEDs, and it lets you turn on and off a lamp using an NES zapper gun. I even used it in a couple versions of the Game Boy Zero. The buttons were connected to some pins on a Teensy board, which is just another Arduino compatible board, and it relayed those button presses into keyboard button presses via USB to the Raspberry Pi. So all that to say, they're pretty darn useful, and you can use them in all kinds of different projects. So I keep referring to the ESP32 as an Arduino board, but really what I mean is it's an Arduino compatible board, meaning you can use it with the Arduino development environment. There are a couple of other ways that you can program it, like MicroPython or Lua, and you're free to use those if you're going to be doing the competition. But in my opinion, the easiest way to get up and running with it, especially if you're new to this stuff, is with Arduino. There are just a ton of existing libraries that you can use, examples and source code that you can draw from, so it's what I would recommend if you're just getting into this kind of thing. So to do any of the really fun stuff using hardware with Arduino, you're going to be using the pins on whatever kind of board you get. And some of them will just have through holes like this that you can either put a wire directly in or connect some header pins to. And some of them, like the ESP32 board that I'm going to be using, have those pins already attached for you, so you can just drop it into a breadboard and start playing with it. And then some of them will have these female header pins on them that you can either connect jumper wires to or put some through hole components directly into it and start playing with it right away without needing anything else. A lot of the larger official Arduino boards are set up this way. But regardless of what kind of board you get, you're going to need to know what each of these pins actually does. Some of them are ground, some of them are power. Some boards will have multiple voltages on them, so maybe one pin will be for 5 volts and one pin will be for 3.3 volts. Some pins will be just general input-output pins. Some of them will be reserved for special kind of buses like SPI or I2C, and some of them do multiple things. And a lot of times they'll have some small writing next to each pin that'll kind of give you an idea of what they do. Sometimes that's kind of cryptic though, and it doesn't tell the full story. Like it doesn't tell if one pin has multiple functions usually. So you'll need to go on your manufacturer's website and look at a pinout diagram for your board to see what each pin does and to see what pin number you should reference within Arduino to actually interact with that pin. Another thing that's really common to find on different Arduino boards is an onboard LED that's tied in with one of these input-output pins on the board. So having that is really handy because you can immediately start interacting with it within the Arduino development environment, either to just kind of play around with, make sure that you have everything set up right, or to use as a really kind of primitive form of output on the board so that you could have it light up when something happens. It's also pretty common to have a reset button. That button, just as the name implies, will reset the board, and on some boards, sometimes you'll need to press that button right before you start uploading a sketch to it. Alright, so now I'm going to show you around the Arduino development environment that I keep mentioning, show you how to set up your board and get it working with it, talk a little bit about the basic structure of a sketch, and then show you how to interact with a few basic components like a button and an LED and a few different types of sensors. So when you first open it, this is about what it'll look like. This area here at the top is where you'll be writing your code. This button here at the top left will verify your sketch, meaning it'll check for any typos or other errors in your code. And this button right next to it will verify your sketch, but then it'll also try and upload it to your board. And then this area here at the bottom is output for if there are any errors when it's verifying it, and it'll also give you some progress feedback for when it's uploading it to the board. If you go to the file menu, you can see that there's an examples submenu. There's some really helpful examples here that you can look at to see how to do things like read from pins both as digital and analog inputs, all kinds of stuff. So I definitely recommend checking those out. If you look under the basic section, there's one called Blink, and that's kind of the go-to example for starting out with Arduino. All that this sketch will do is blink the onboard LED on and off, but it's a really good starting point to see how a sketch is structured and how to do a few different things. But before we can actually upload this to our board, we need to tell it which one we're using. So if you go to the tools menu, you can see there's a board section, and out of the box you'll see that you only have access to the official Arduino ones. So if you're using one of those, you should be able to just select it here and that's it. But if you're using one from a third-party manufacturer like we are, then you're gonna have to do a few things to make it show up in this list so that you can use it. And it's gonna vary depending on what boards you're using, so check your manufacturer's website and they should have instructions for getting it up and running with Arduino. For our particular board that we're using, you can just go to the official ESP32 repository on GitHub and scroll down, and there are instructions for installing it on Mac, Windows, and Linux. They all look pretty simple, but I'm using a Mac here, so all I have to do is copy these commands and run them in a terminal. I haven't set it up on Windows or Linux, but neither of those look too difficult, so just follow the instructions there and you should be good to go. After that's done, restart the Arduino IDE, and then you should see a bunch of new boards show up in this list. The one that we're going to be using is at the top, ESP32 Dev Module. And there are a few other settings that you can change on your board, like some boards there will be different variants that have different clock speeds, different flash sizes, and things like that. For this particular board, you should be able to just leave everything as it is there. So I click verify here, and you can see that it spits out an error because it doesn't know what LED built-in is. Depending on what board you're using, you may or may not get this error. On a lot of Arduino boards, that will already be defined for you because the built-in LED is usually located at either pin 13 or pin 6. But for whatever reason, that's not set up out of the box on this board. So we can fix that by defining LED built-in up here at the top, and the LED on our board is at pin 2. So now that should clear up that error and we should be able to upload it to our board. So if you see an error like this when you try and upload the sketch, that probably means that you need to install a driver to make it work with your computer, just like you would with any other new hardware. So for this particular board, what we need is a driver for this tiny chip right here. That's a USB to UART chip. That's what makes it so you can plug it into a USB port on your computer and program it. So you just go to their website, download the package, and install it. So after you've installed that driver, you'll want to go back to the tools menu, and if you go to the port submenu, you'll see a new option that wasn't there before. So go ahead and select that, and now it should upload. And hopefully if you've got everything set up right, you should see the blue LED blinking on your board. So again, check out the link in the description. I'll have a blog post where I'll put links to everything that you need for this board. And if I realize that I missed anything in this video, I'll put any missing info or any corrections or things like that in that blog post. Now, as short and simple as this sketch is, it still demonstrates several important concepts that you use in basically any Arduino sketch that you write. So you see we have two functions here, one's called setup and one is called loop, and these are special built-in functions that will automatically get run for you whenever the board gets powered on. The setup function will get called once, right when the board turns on, and that is where you'll set up your pins. You'll tell it how you're going to use them, whether they're input or output or analog or digital, that kind of thing. This is also where you'd want to initialize any variables that you're going to use in the rest of the sketch. And then right after the setup function finishes, the loop function will start running over and over again until you turn off the board. And this is kind of the structure that you'll find in pretty much any Arduino sketch that you look at. The other functions that are being called within the setup and loop functions are built-in Arduino functions that, again, you're probably going to use no matter what you're doing. So here within the setup function, we're calling the pin mode function, and we're telling it that we want the LED pin to be set to output. So we're not going to be reading anything from it, we're going to be turning power to that pin on and off. And this right here, the LED built in, remember we defined that up here. You could use a number here if you wanted to. Like if you had an LED hooked up to pin 5, for example, you could just put the number 5 here instead. It's a lot easier to either use variables or define them up here like this so that you don't have to remember what pin number you used, and also so that if you change the pin number, you'd only have to change it in one spot. Here in the loop function, we're calling digital write, which means that we're either turning it all the way on or all the way off. We're doing that on the LED pin, and we're setting it to high, meaning we're turning that pin on. Then we call delay, which as you might expect will just kind of pause there for however long you specify. It's in milliseconds, so putting 1000 here will make it wait for 1 second before moving on. Then we're calling digital write again and turning the LED off by setting that to low. Then it waits again for 1 second and it goes right back to the top of that loop function. So what it'll wind up doing is turning the LED on for 1 second, then turning it off for a second, and just doing that over and over again. So to make this sketch a little bit more interesting, I've made it so that when you push a button, it will turn on the LED for 1 second. So you can see I've defined another pin up here, pin number 13. And then here in the setup function, I'm calling pin mode again, and this time I'm giving it the button pin that I just defined, and I'm telling it that I want to use as an input pull-up. This means that you're using it as an input with a built-in pull-up resistor. And I'll link to a really good article from SparkFun about what input pull-up resistors are, why you need them, and how to use them. But a lot of microcontrollers, like the one that we're using, have pull-up resistors on the input pin so that you can use them with things like buttons really easily. Then down here in the loop function, I've changed it so that if the button is pressed, we turn the LED on, wait for 1 second, and then turn the LED back off. And to check if the button is pressed, we're using kind of the opposite of digital write, which is digital read. So we're calling digital read and we're feeding it the button pin. But you notice we've got an exclamation point here at the beginning. So we're actually checking for this statement to be false, which might seem counterintuitive. You might expect that to be true if the button is pressed. And again, that has to do with how input pull-up resistors work. So check out that link that I'll put in the blog post. So now we can run it, and you can see that when I push the button, the LED turns on for 1 second and then it turns back off. So this is still really short and simple, but it just kind of illustrates how easy it is to get started with Arduino and messing around and doing stuff. Within this example, we're reading and writing to 2 different pins and making a light come on, all within less than 20 lines of code, so that's pretty cool. So now let's see if we can make this even more interesting by controlling the LED using a few different types of sensors. If you go look at all the different kinds of sensors that you can get, you'll see that there are a few different ways that they interface with whatever board you have them plugged into. So I'm going to go over a few different kinds of those and make the LED turn on and off with those. But something that I want to mention real quick, when you're looking at sensors, you want to look at the voltage that that sensor uses to see whether or not it matches the voltage on the board that you're using, which in our case for this ESP32 is 3.3 volts. That sensor is going to be connected to some input pins on your board, and if, for example, that is sending 5 volts when your board only supports 3.3 volts, that's not a good thing and you can even break things. So if you have a sensor that's 5 volts and you just really want to use it and you can't find a 3.3 volt version of it, what you want to get is something like this. This is a bidirectional logic level converter so that you can convert between 3.3 volts and 5 volts for whatever you have plugged into it. And the reason it says logic level is that it's not really made for powering peripherals or anything like that. It's really meant for the signal that the sensor is sending to convert that between 3.3 and 5 volts. They're really cheap. You can get them for a couple of dollars. On Amazon, they even have packs of 10 for $10, so it's not a big deal to grab one, and they can be really useful if you run into that voltage incompatibility. So the first and kind of simplest kind of sensor that you'll find is one that you just hook up to power and ground, and then there's a third pin that just sends a signal when it's triggered. So it's not actually sending any data on that pin, it's just setting it to high. So a good example of that type of sensor is this passive infrared sensor. This is the one that I used in my Halloween project last year. And when it senses motion, it just sets the output pin to high. So about as simple as just using a button. And the code is pretty similar too. I've defined a pin up here for the infrared sensor. Down here I'm setting the pin mode to that to input. So you notice I'm not using an input pull-up resistor there. We just set it to input. And then down here in the loop, every time that runs, we call digital read on that pin. And if that is high, so again, since we're not using that input pull-up resistor, we're actually checking for this statement to be true instead of false like we were at the button. So if this is true, then we turn the LED on, we wait for 1 second, and then we turn it off again. So here you can see it running, and when I put my hand in front of the sensor, the LED turns on for a second. So that brings us to this next kind of sensor. This is a sound sensor that will send a range of voltages that you can read from as an analog input on your board, which you could use to make something happen if there's a loud sound or even if it got too quiet. So here at the top we've got our sensor pin defined, and we're setting it as input in our setup function. Then down here in the loop, this time we're reading the value of that sensor using analog read since it's a range of values. And then we're doing something that I haven't shown you yet, which is printing out the value of that sensor to the serial monitor. So if you press this button up here, that will bring up a new window, which is the serial monitor. This lets you print things out so that you can see what's going on in your program without having to rely on something like an LED. Setting it up is really easy in your sketch. You just need to call serial.begin in your setup function. This number in here is the baud rate. You need to make sure that this number matches this number right here in your serial monitor. That's the speed that it's sending data to be read from in this window. So if those numbers don't match, then you'll just get a bunch of garbage in this window. So once we've read the sensor value, we're printing it out, and if the value is over 110, then I'm turning the LED on. Otherwise, I'm turning it off. So it's running now, and these are the values that it's printing out. And so if I spray some canned air on it, you can see that those values jump quite a bit, and the LED turns on. Pretty cool. And these kinds of sensors are nice because it makes it up to you to determine the threshold that whatever type of sensor you're using is actually considered tripped. So the last kind of sensor that I want to talk about is one like this, which is a sensor that does barometric pressure, temperature, and altitude all in this tiny little module. So in contrast to the two sensors that we've just looked at, rather than just reading whether a pin is on or off or reading a range of voltages from one of the pins, this actually sends some data to your board that you can read and interpret. This particular one does it using the I2C interface. So it's a couple more steps to hook up and get running, but it's not bad. Another reason I like this particular ESP32 board is it's pretty well documented on the product listing on Amazon. They have a couple links that you can follow for pinout diagrams and everything like that. And one of them is actually the official ESP32 GitHub repository from Espressif. So if you go on there, you can see a wiring diagram, and that will show you which pins you need to use for SDA and SCL when you're wiring up this sensor. A lot of the other boards use totally different pins, and sometimes it's not easy to track down which ones you need to use. So we'll have 4 pins to connect. We'll have power, ground, SDA, and SCL. And usually when you get a sensor like this, there will already be an Arduino library out there and some examples that you can use to get going. So check with the manufacturer or even the Amazon listing if you buy it on there, and there's usually some links that you can follow. So for this particular sensor, Adafruit actually has a library that you can use to read from it really easily. Now, it won't be included with the Arduino IDE out of the box, so you have to add it. So if you go up here to the sketch library and look at the include library menu, you have the option to add a library as a zip folder. Some manufacturers might have an Arduino library that's just a zip file that you download and load it in here this way, but some of them you can go up here to the manage libraries, and that will bring up this window where you can search for libraries. So here we'll type in BMP180, which is the sensor that we're using, and then this Adafruit library right here is compatible with that. So we just click install on that, and now we can go over here to the file menu, and under examples there's a new option for that library that we just installed. So if we open up that example, they've got a lot of code here that we can look at and see how this library works and see how to use it in our project. So again, they're using the serial monitor to print out some information as it reads stuff from the sensor. At the top you can see they're defining an object that they've named BMP, which is this Adafruit underscore BMP085 class that they've defined in their library. Then down here in the loop, they're calling the read temperature function on that BMP object. They're actually doing that within the serial.print function, so it'll print out the result of that function. Then down here they're doing BMP.read altitude, and then further down they're reading the barometric pressure and printing that out as well. So now if we run it, we can see that it's printing out that information over and over again within that loop function. So let's say that we only care about the temperature. Well, we can just rip out everything that we're not using and strip it down to just the temperature reading that we care about, and there we go. It's printing out the temperature over and over again, and then when I put my finger on this sensor, you can see that it warms it up and you can see that temperature go up. So now let's make it so that it turns the LED on and off depending on what the temperature is. So we'll set up our LED pin here. We'll call pin mode and say that it's output. We'll change this a little bit so that we read the temperature outside of that print function. We'll still print it out so that we know what it is. And then down here we'll say if the temperature is above 29 degrees Celsius, then we'll turn the LED on. Otherwise, we'll turn it off. And then there we go. If I put my finger on the sensor again to warm it up, you can see that the LED turns on. So I know these are pretty simple examples. I mean, all we're doing is turning an LED on and off, but it demonstrates how you can use a sensor to determine when you want something to happen. You could make anything happen when these sensors are triggered. So for example, on my smoke sensor that I had, if that sensor reaches a certain level, I'm calling some code that calls a web service that sends myself a text message when that happens. So really, I know it's kind of cliche, but you're really only limited by your imagination to what you can have these things do whenever it reads something from a sensor. Alright guys, well I think that was about everything that I wanted to cover. I know this was a long one, but I hope it helped you get started with Arduino. And if you make something cool, then definitely stop by the forums and show us what you made, even if you're not planning on doing the competition or if that's already passed by the time that you watch this. Again, check out the link in the description. It should have everything that I used here, including the ESP32 board that I used, the sensors, some sample code, some links to help you get started with programming, and things like that. As always, thanks for watching guys, and I'll see you next time.